this is Britt Caswell with another example video. In today's video, I'm covering example 4 from section 7-3 in the SavvasRealize Algebra 2 textbook. The goal of today's video is to evaluate reciprocal functions. Alrighty, so to start out, what we're going to do is we start with a unit circle. Alright, and the reciprocal functions come from finding our sine, cosine, and tangent and just flipping those upside down. That's what a reciprocal is. So in this case, I'm looking for a 135-degree angle, which lies right here on the unit circle. 135 degrees, here's 90, plus an additional 45 makes this 135 degrees. And I'm looking for this ordered pair right here. So if I take a little reference triangle, which I'm going to do this one that I'm coloring in kind of junky yellow, I can go ahead and find that ordered pair by finding the x and the y values there. So let's go ahead and do that. We're going to pretend like I know how to draw. There we go. Now, remember, with the 45, 45, 90 right triangle, you have a hypotenuse of 1, and in all our 45 degrees, the side lengths are root 2 over 2. Okay, you can get that from my previous videos where I've looked at unit circles. You can get it from the Pythagorean theorem. Just understand from special right triangles. Every time you have a 45-degree reference angle, you're dealing with root 2's over 2's for your sine and cosine. It's just the signs on them that changes. So this one's coming backwards on the x-axis, so this is a negative root 2 over 2 for my cosine, and it's coming up on my positive y-axis, so that's a positive sine. Alrighty. So now the secant of this angle measurement is equal to 1 divided by my cosine of this angle measurement. So what that means that I need to do is I need to just take my cosine, which is my x value, and flip it on its head. Alright, so this is the same thing as 1 over negative root 2 over 2. Or the way that I think about it is it's the same as negative 2 over root 2. Now I don't like this because I have a radical chilling here in the bottom, and we don't like radicals in our denominator. So what I'm going to do to find my secant is I'm going to multiply by the value of 1, that's what this red stuff is, that will cause that radical to cancel itself out. So in this case, my secant is equal to negative root 2 if I simplify. Because root 2 and root 2 equals 2, and it cancels with that one up there, leaving me with just negative root 2. Alright, now my cosecant is equal to 1 over the sine of 135. Now understand, my sine and my cosine are the same thing, with the exception of the sine. This one's going to be positive root 2 over 2 because it's a positive y value. So I don't have to go through all this arithmetic again. I know that I'm dealing with the root 2, and it's going to be positive because my sine was positive. So just remember, keep it kind of simple here. So now my cotangent of 135 degrees is the same thing as 1 over my tangent of 135 degrees. So instead of doing my sine divided by my cosine, I would do my cosine divided by my sine. So I'm doing negative root 2 over 2 divided by root 2 over 2, which evaluates to negative 1. Alrighty, so now let's go ahead and let's do it with these other ones. And what I'm going to do is I'm going to kind of skip some of these middle steps to save myself space. I'm going to evaluate the sine, cosine, and tangent, and then just flip them upside down. Please don't judge me. Alrighty, so first I need to draw my unit circle, right? That way I can get my ordered pairs. So 210 degrees is between 180 and 270. So my reference angle's chilling out somewhere over here. Now I know that this is 180. So 210 minus 180 makes this a 30-degree reference angle. Alright, so if I go to draw out this like reference triangle here, making it a little bigger so I can actually see it, right? So here's 30 degrees, here's 60 degrees, here's 90. So I know my hypotenuse is 1. I know that the short side across from 30 is half of that hypotenuse, so it's 1/2. And 60 is the square root of 3 times my short leg. So now if I think about my signs, I have a negative y value here, so this is a negative 1/2. And I have a negative x value because I'm coming backwards, so this is a negative root 3 over 2. Okay, so now let's go ahead and do the pieces of it. So I know that the sine of 210 degrees is equal to that y value, which is negative 1/2. So if I'm finding my cosecant of 210 degrees, I'm going to take that negative 1/2 and flip it upside down. So I get negative 2. Alright, now my cosine of 210 degrees is going to be my x value, which is negative root 3 over 2. So my secant of 210 degrees is going to be negative 2 over root 3. But remember, we don't like having a radical in the bottom, so I need to multiply by the one number that equals 1 that causes that radical to cancel out. So when I do that, I get negative 2 root 3 over 3. Now I'm going to go through and I'm going to do my tangent kind of the same way. Now when I go to do the tangent of 210 degrees, it is my sine divided by my cosine, so negative 1/2 divided by negative root 3 over 2. But I'm not going to go through all the calculation for it because I'm going to have to rationalize. And I don't want to have to do that twice. Don't freak out about that. So my cotangent of this thing is going to be negative root 3 over 2 divided by negative 1/2. And that's what I'm actually going to keep change flip here. So negative root 3 over 2, change this division to multiplication, and flip 1/2 to be negative 2 over 1. So my 2's cancel out, my negatives cancel out, and I'm left with negative root 3 over 1, I'm sorry, positive root 3 over 1, which is just root 3. Alright, so now let's look at B. Now I worked with B with another student in tutoring, and he kind of got a little thrown off on this one because of his fractions, which was interesting to me. Fractions can be a little bit of a doozy for people. So I'm just trying to center this circle a little better. There we go. Alrighty, so the first thing that he did, which I thought was really great, was he recognized that 10 and 4 can be reduced. And so I'm actually going to do that just because I think it comes out a little cleaner. So this is the same thing as negative 5/2 pi. And the way that he was thinking about it was as negative 5 pi over 2, and I think that's lovely. Because remember, pi over 2 is 90 degrees. So if I'm doing negative 5 pi over 2, what I'm going to do is I'm going to go around 90 degrees 5 times. Alright, so just getting my colors right. So here's my initial side. So here's negative 1, 2, 3, 4, 5. And so my reference angle is actually right here at 3 pi over 2. And so if I write out the ordered pair of this point, I get negative, or 0, negative 1. And so that's going to make my calculations a whole lot easier for my other values, right? So let's try it. So my sine My sine of negative 10 pi over 4 is equal to negative 1. So my cosecant of negative 10 pi over 4 is negative 1 flipped upside down. So 1 over negative 1, which is negative 1, and that is so easy. So now my cosine of negative 10 pi over 4 is equal to my x value, which is 0. So my secant of negative 10 pi over 4 is 1 over 0, and that's undefined because you can't divide by 0. So then my tangent of negative 10 pi over 4 is my sine divided by cosine, which is negative 1 divided by 0, which is also undefined. But my cotangent is 0 over negative 1, which is just 0. So there we have it, guys. That is how to evaluate the reciprocal function. Until next time.